All right, let's go through this problem. So this is properties of exponents, okay? So looking at this, we've got to piece by piece simplify it. We've got to not break any rules. So we know the properties of exponents. Any base raised to the 0 power is equal to, not 0, what's it equal to? 1, okay? Any base raised to the 0 power is equal to 1. We also know when you multiply the same base, then you can add your exponents. If you're dividing the same base, you'll subtract your exponents. You subtract the top from the bottom. Then we know if we have a bunch of stuff that have powers and we're raising it to another power, then we multiply our powers. Raise it to power to a power and we multiply the powers. And then we also know if we have a negative exponent, we've got to take the base and flip it over a fraction, either down or up, depending on where the base is sitting with the negative exponent, and that will fix the negative exponents. So that's all properties of exponents. So let's simplify this one. So we have 2x to the 0. So first of all, I'm going to simplify it in pieces first. 2x to the 0. So I'm going to ask you, looking at this one, is 2 raised to the 0 power? No, it's 2 times x raised to the 0 power. So x to the 0 power is 1. So what we have is 2 times 1. Notice how I did not say add. Do you see any addition signs in between the 2 and the x? No. So x is 0 became 1. So that's just 2 times 1, which is 2. So you should be doing this on your blast from the past, right? Let's move on to the next section. Looking at this piece, we have all that stuff inside raised to the third power. So we're raising a power to a power. So we multiply the powers. Now, 80% of you forget to do this part. Is 3 raised to the third power? Yes, it's in parentheses. It's all this stuff raised to the third power. So don't forget that. So we have 3 to the third power. You better not miss that on this upcoming. I'm going to put some of these on the upcoming test. You better not miss that one. And then we have x to the negative 1 raised to the third. So we multiply the powers because we're raising a power to a power. So we get negative 3. And then right here, y to the 2 times 3, 6. Very good. Any questions? You're sure? Okay, so then we look at it and simplify it if we can. 3 to the third power is 3 times 3 times 3. Not 3 times 3 once. It's 3 times 3 times 3. 3 times. So 3 times 3 times 3 is 27. So we have 27, x to the negative 3, y to the 6. Do we have any negative exponents we need to fix? X to the negative 3. So we're going to draw our line, flip anything with a negative exponent. The whole thing, the whole base comes to the other side of what you're flipping. So we're going to bring that down to the bottom. It's now positive 3. So what we have then is on top, 27, we have y to the 6, and on bottom, we have x to the third. You're still struggling with this stuff, guys. Does that make sense? You sure you see how I did that? You have no questions. The 2. Oh, we're not done simplifying. I'm just saying, do you have any questions on this piece? Okay. All right, and then let's continue to simplify. So then right here, we have 5 and x raised to the 0 power. So are both of them raised to the 0 power? So we have 5 to the 0, x to the 0. What's any base raised to the 0 power? So we have 1 times 1, which is 1. So if you look back, we were adding, and we were adding. So what we have then is 2. Can I write right here? So we have 2 plus 27, y to the 6 over x to the third, and then plus 1. Are any of those like terms? 2 and 1. 2 plus 1 is? So we have 3 plus 27, y to the 6 over x to the third. And then we can't add these two things. They're not like. Any questions? So yeah, that problem took quite a few steps, and there's a lot of room for error. You're going to see stuff like this, though. Okay, so no questions on that. Look at it in pieces, make the correct choice with properties of exponents. All right, no questions? Then let's move on to new stuff. So today is our first lesson in our unit of solving, 3-1. So we're going to be solving radical equations. I need you to work really hard today. We have a lot to learn, okay? So solving works the same with all equations. We know how to solve linear equations. We know how to solve quadratics. Two different, they all include some of the same things though. We apply inverses to get the variable that we're trying to solve for alone, right? We apply inverses to get it alone, piece by piece. So remember with inverses, addition undoes subtraction, and subtraction undoes addition. They undo each other, they're inverses, so they undo each other. Then with multiplication, it undoes division, division undoes multiplication. You all know this, I'm hoping by now. So looking at these examples, you don't need to write them down, just look with me for a second. These are very basic examples. If I said solve for x and we had x plus 2 is equal to 3, we're trying to get x alone. So since the 2 is being added to x, to undo addition, we would subtract 2 from both sides of the equation. So then we would have x on this side because that adds up to be 0. So left is x, and then 3 minus 2 is 1. Does everybody see how I did the most basic of solving on that? Okay, let's look at this one. Solve for x. 3x is equal to 9. 3 is being multiplied to x. So how do you undo multiplication? Division. So I divided both sides by 3. Probably the, oh, no. So we divided both sides by 3, and we get x. So then 3 divided by 3 becomes 1. So then 9 divided by 3 is 3. So we have x equal to 3. Everybody gets that, right? That was very basic. That's like what you learned in middle school. All right, so once again, just looking at these examples. If we have x minus 3 is equal to 5, we're trying to solve for x. To get x alone, since this is subtract 3, we would add 3 to both sides of the equation. This would add up to be 0, and that would add up to be 8, so we get x is equal to 8. This is the one that throws people for a loop. So looking at this, we have x divided by 3 is equal to 10. I just said x divided by 3. How do we get x? How do you undo division? Multiplication. So I multiplied both sides by 3. So then our 3's divide out. And then we have 10 times 3, which is 30. Everybody's good with the basic solving of this. Okay. All right, so here are the steps. You can take a picture because I don't want to wait for you to write it down. So these are the steps to solving a radical equation. First, this is the most important part. First, we must isolate the radical completely, which means we have to get the radical all by itself, completely alone. Nothing added to it, nothing subtracted to it, nothing multiplied or divided to a radical. Then, so we'll do that using algebra. Then the second step, once you've isolated your radical, you'll undo the radical using the correct inverse. So we know that inverses undo each other, so you'll undo the radical by applying the inverse. And then third, after that, you'll piece by piece, then algebraically solve for x, if it's not already alone. So once you've undone the radical, then piece by piece, you'll solve for x using algebra again. And then fourth, and the most important part is this. You must check answers for extraneous solutions. So you might have done all your answers correctly and gotten these answers. Let's say you got 2 answers, for example. You have to go back and plug those back into the original problem and check them, because we're taking these problems, guys, and as you can see, we're manipulating them. We're doing all this stuff, and even when we perform the correct algebra and get a correct answer, we can introduce extraneous solutions, because once we manipulated it so much, it can introduce extraneous solutions, meaning even though you solved correctly, if you plug that back in to check it, and it is not truly a solution, you throw it out. Does that make sense? So you'll go back and check your answers. If it comes up with a true statement, you get to keep it. If not, you'll throw it out. I promise, guys, this is in the core. They will check to know if you know how to solve radical equations, and they will put an extraneous solution on some of them to make sure you're checking for that. And so you have to just check all your answers, which a lot of students are like, it sucks, but you know what sucks worse? Getting it wrong on the test, even though you went through all that work and solved, and then you didn't check your answers, so you circle both of them, and there's either no solution or one of the solutions you toss out. All right, any questions on that? We all have the picture ready to practice. That's all we're learning. Now we just have to practice it. A couple things. Okay, so let's solve this one. We're going to start with simple square root equations. So you guys are pretty good at root equations, square roots. So we have 3 plus the square root of 2x minus 3, which is equal to 8. Couple of things to notice. This 3 is being added on the outside of the radical. Does everybody see that? Then 2x minus 3 is all underneath the radical. Does everybody see that? And it's equal to 8. So we know, if you read the steps, it says, first, isolate the radical. That's our first step. Get it all by itself, using the correct operations. So if this 3 is being added to this, how should we get 3 to the other side of the equation? Good. Subtract 3 from both sides of the equation. Now over here, on the left, that adds up to be 0. Now leaving you with, on the left, the square root of 2x minus 3 is equal to, very good, 8 minus 3 is 5. Questions on that? We've isolated the radical. There's nothing multiplied to it. There's nothing added to it. Now your steps will say, now get rid of the radical, applying the correct inverse. So how do we undo the square root? Square. Very good. How do you undo squares? Square roots. Squares undo square roots undo squares. So this is a square root, so we're going to square both sides of the equation, and I'm going to put it in parentheses. So then our root cancels out with our power on the left, leaving us with 2x minus 3. Questions on that? On the left. And that's equal to, what is 5 squared? 25. Questions on that? Okay. Now, we got rid of the radical. Do you see how the radical's now gone? So continuing. Then from there, the steps say, now piece by piece solve for x. Get x alone. So from here, what's my next step? Add 3 to both sides of the equation. So then that adds up to be 0. So I have 2x is equal to 25 plus 3. 28. And now to solve for x. Divide both sides of the equation by 2, and we get x is equal to 14. Questions on that? Now, yes, that is our solution as far as we know. We don't know for sure until we check it in the original problem. So now I go back up here. I leave myself a side over here to go ahead and check our answers. So we're going to plug it back into the original problem. So we're plugging it back in for x, since that's what we solved for. So the original equation was 3 plus the square root of 2 times x. What was x? So 2 times 14 minus 3, and that better be equal to 8. Does everybody see how I plug it into the original problem? Then I'm going to continue to simplify. So I'll have 3 plus the square root of 2 times 14 is 28. So we have 28 minus 3 is equal to 8. Then I'll continue to simplify. So we have 3 plus the square root. 28 minus 3 is 25, which is equal to 8. And the square root of 25 is 5. So 3 plus 5 is equal to 8. So let's see, do we end up with a true statement? 8 is equal to 8. Is that a true statement? Yes, that is a true statement. So yes, that is a solution we're going to keep. That is our answer. Does that make sense? We checked it. It worked. It's a true statement. If it wasn't true, we throw it out. And in this one, it would be no solution. Does that make sense? But we checked it. It's truly a solution because it gave us a true statement, so we're all good. Any questions? Okay, another one. Okay, so we have solve for x. So we have the square root of 2x plus 3 minus 7 is equal to 0. All right, so let's go through and follow our steps. Our first thing is to isolate the radical, get it all by itself. So what should I do first? Add 7 to both sides of the equation. So now over here on the left, that's going to add up to be 0, which is what we wanted, leaving us with the square root of 2x plus 3, which is equal to 0 plus 7 is 7. Now our radical is completely by itself. So now we're going to get rid of the radical, applying the correct inverse. What does the square root? Square. So I'm going to square both sides of the equation. So then our root cancels out our power on the left, leaving me with 2x plus 3 is equal to 7 squared is 7 times 7, which is 49. Then piece by piece. Now the next step is piece by piece, algebraically solve for x. So I'm going to subtract 3 from both sides of the equation. So I have 2x is equal to, right? 46 And then what will I do to get x long? Divide both sides of the equation by 2. So x is equal to 23. Now we'll quickly check it. Make sure it's not extraneous. We've manipulated this, changed it up a little bit. We've done it correctly, but we've got to check it. So we have the square root of 2 times 23 plus 3 minus 7 better be equal to 0. I plugged it back into the original. So this is where you'll go, okay? So 2 times 23 is 46. So we have 46 plus 3 minus 7 is equal to 0. So we have the square root of 49 minus 7 is equal to 0. What is the square root of 49? 7 minus 7 is equal to 0. Is this a true statement? 0 is equal to 0. It is a true statement. We've checked it. We know we can keep that answer. So our answer is x is equal to 23. Questions on that? Okay. Last one, then I'm going to let you work. So solve for x. We have 3 square roots of x minus 2 is equal to 4. So this one's going to take an extra step here. So everybody stay with me. 3 square roots of x minus 2 is equal to 4. What's my first step? Isolate the radical. So we got to get the radical along. What would we do? Add 2 to both sides of our equation. Very good. So then that adds up to be 0. So that's good. So we have 3 square roots of x is equal to 4 plus 2, 6. All right. Now, is our radical isolated yet? No, it's got to be completely alone. What do we do? Good. Divide both sides of the equation by 3. Very good. Does everybody understand why I divided by 3? Wasn't 3 being multiplied? Okay. That becomes 1. So we have the square root of x is equal to 2. All right. Now we've isolated the radical. How do we undo the radical? We raise it to the inverse. So with this one, it's second power on both sides. I'm going to put it in parentheses. So then with that, our root cancels out our power, leaving us with x is equal to 2 squared is 4. And then we will check it. So we have 3 times the square root of 4 minus 2 is equal to 4. I'm plugging that back in for x. So we'll have 3 times, what's the square root of 4? 3 times 2 minus 2 better be equal to 4. So 6 minus 2 is equal to 4. So 4 is equal to 4. Does everybody see how I did that? Checked it. That's a true statement. So we get to keep it. So that's our answer. All right. Practice problems. So 1 through 4. Work hard because we've got to move on. These are the easy ones. These are the warm-ups. So we've got to move on. So work hard. Ready, set, go. Work hard, hard, hard. You really will, because if you don't, that was the warm-up. We haven't even gotten into the good stuff yet. All right, so pay attention to little details. So looking at this, we now need to know, which you guys actually should definitely have learned this last year, but So we have a base raised to a rational exponent. Remember that rational means fraction. So if we have a base raised to a fractional exponent, it's actually the exact same thing as a radical. It's just written in 2 different forms. This is apples, this is applesauce. So you can rewrite some base raised to the n over n power. That's the exact same thing as the nth root of x to the nth power. So rational exponents are roots. Roots are rational exponents. Does everybody understand that? Roots are rational exponents are roots. This is one way of writing it. This is another. You could rewrite it either way. So like I said, apples to applesauce. Now here's a little trick I give my students to help them remember how these work, because it's very important to understand. Everybody look up here. Do you see how n is on the bottom? That is what signifies our roots. Does everybody see that? And then the power's on top. That's what signifies our power. So if you picture, and I'll say it many times through the year, if you picture a picture of a flower, with a flower, roots grow on the bottom, right? And then the sun shines down and the power comes from the top. So power's on top like the sun, roots are on bottom like the roots of a flower. So roots on bottom, power's on top. Roots are on bottom, power's on top. So hopefully that picture will help you remember that. Does everybody understand? Roots are on bottom. Power's on top. Just like a flower. Is everybody okay with that? Okay. So let's say we wanted to write this as this. We would use our root on bottom, right? And our power on top. Does everybody get what I'm saying? Okay, let's practice. So let's rewrite this as a radical. So we have x to the third power, x to the third power. Oh, sorry, I shouldn't say it. X to the 3/2 power. So first of all, what's my root? Roots are on bottom. What's my root on this one? 2. So this is the square root of x to the what power? 3. Now I didn't write 2 because we know that square roots goes without being said that there's a 2 there, right? Does everybody see how I rewrote it? Okay, let's rewrite this one. X to the 5/7. What's my root? So it's the 7th root. Roots are on bottom just like a flower. 7th root of x to the 5th power. Power's on top like the sun. Now everybody think back. When we were learning how to simplify radicals, when we took the square root and even root, we had to account for the plus and minus root, right? So if we're taking an even root, we've got to put the plus and minus answer. Does that make sense? So in this one, we would have had to put the plus and minus answer, right? Because it's an even root. With this one, would we need the plus and minus answer? No, it's not an even root. Does everybody understand what I'm saying? Okay. So also, everybody look up here for a second. You don't need to take notes on this. I want to make a point because I think this will help you all see in a second inverse is better. Let's say we started with 2/3. Everybody just look. If we started with 2/3, notice if I take and multiply 3/2. Let's say I grab that and flip it and then multiply that to the first thing. So I'm going to multiply 2/3 to 3/2. We multiply straight across and we get 6/6, which is 1. So do you see how when I multiply the reciprocals, those are inverses of each other because they become 1. So 4/5 times by 5/4 is 20/20, which is 1. So look at this, guys. 2 times 1/2. Well, technically, this is 2 over what? 2 over 1. So the reciprocal would be 1/2. And if we multiply straight across, we'll get 2/2, which is 1. Does everybody see how you can undo things, fractions? Okay. All right, so then here is the rule. So if we have radicals of this form, x is raised to the n/m. So we're seeing radicals as rational exponents, but we know they're equal. So let's say we're trying to solve for x raised to the n/m is equal to something k. Now to undo n/m, you'll raise each side to the m/n power. So you'll raise each side to the reciprocal power, just like, did you see how we just undid all those fractions? We're going to do the same thing with this. So everybody look, if I have this, x raised to the n/m, if I want to do n/m, I'll raise both sides of the equation because I can't just do it to one side. I'll raise both sides of the equation to the reciprocal. So that'll be m/n. So wouldn't that cross out and become 1? Yes, right? There's an n on top and n on bottom, and m on top and m on bottom. Okay, so that would become 1, but we got to do it to both sides evenly or else we change the problem. So I'm raising both sides to the m/n power. So then on this side, that will become 1. Those become 1. So that will leave us with x. So x is equal to k raised to the m/n power. So does everybody kind of see how we're going to do it? It's going to make more sense when we actually practice it with an actual problem, but I just wanted to give you that as well. Now also keep in mind, if you have an even root, if you're raising both sides to an even root, you must account for the plus and minus answer. That gets students every time. So once you've raised it to both sides, you'll look over here and say, is my root, which is on bottom, is it an even number? If so, you have to put the plus and minus answer of what you get. Does that make sense? Because we know if we take the even root, we have to account for the plus and minus answer. Okay. So here's our first example. I'm going to do number 5 with you on the worksheet. So if you want to do it right on there, that's fine. So it says, solve for x. So we have 3 times x plus 1 raised to the 2/3 power, which is equal to 12. Now the steps I gave you to begin with are the same here. We've got to isolate the radical. So let's look at this. What part is the radical? Well, we know rational exponents are radicals, right? So all this stuff is in the radical, right, everybody? Is everybody okay with that? Okay, so we've got to isolate the radical. So we've got to get the radical completely by itself. So what should I do? Good, divide both sides by 3. Very good. So then 3 divided by 3 becomes 1. We got that. We undid that. So that's perfect. So we have x plus 1 in parentheses raised to the 2/3 power on the left now, which is equal to 12 divided by 3, 4. Is our radical completely alone? Yes, nothing's added to it, nothing's subtracted, nothing's multiplied or divided. All right, now we need to undo the radical. So we're going to raise both sides to the reciprocal power. So I'm going to raise this side and this side to the reciprocal power of the root. So what's the reciprocal of 2 over 3? 3 over 2. Very good. So 3 over 2. Raise both sides to the 3 over 2. Now once again, guys, over here, when we raise a power to a power, we multiply the powers, right? Yeah. So we're going to get 6 over 6, which is 1. So really, these cancel out, leaving us with x plus 1. Good, x plus 1. Does everybody understand? Which is equal to 4 raised to the 3/2 power. Now, is it an even root? Yes, roots are on bottom. That's an even number. So we've got to account for the plus and minus answer. So this is where you'll take your calculator. I want to know, what is 4 raised to the 3/2 power? You go like this on your calculator. 4 in parentheses, 4 raised to the, I'm going to put that, you need to put the exponent in parentheses. So it was 3/2 power, right? So 3 divided by 2. 8. So now your calculator is only going to give you the positive root, but we know we have to account for the plus and minus root. So the answer is 8. So we've got to put plus and minus 8. So we have plus and minus 8. Now from here, I'm going to split that up. What that really is then is x plus 1 is equal to positive 8, and x plus 1 is equal to negative 8. Does everybody see how I just split it up? No, let me bring it up. So I split it up. X plus 1 is equal to positive 8, and x plus 1 is equal to negative 8. So that I can solve, okay? And then from there, we'll solve for x in each case. So I'm going to subtract both sides by 1. So we get x is equal to 7. Then over here, that's one of our answers. We're going to get x alone. What do? Subtract 1 from both sides. So we get x is equal to negative 9. Very good. We have 2 answers. Now we need to check them for extraneous solutions. So we have to check both of those answers. Any questions on how I got them? Okay. Now we have to quickly check on, I'm going to do it a little bit quicker. I'm going to use my calculator. So I just type it in. So we got x is equal to, I'm going to check x is equal to 7 first. So I plug it into my calculator. I'm going to do 3 parentheses, and then I'm going to do 7 plus 1 raised to the 2/3. Use your parentheses correctly. Is equal to 12. So I'm going to just check it using my calculator. So it's 3 times 8, right? Raised to the 2/3 power, everybody? So it's 7 plus 1, which is 8, right? So we're going to do 3. So 3 times, in parentheses, 8 parentheses raised to the, I need to put it in parentheses. Parentheses. Oh, I'm clicking on the wrong thing. Raised to the parentheses. It was 2/3, right? In the beginning? 2/3. 2 divided by 3. I check it. 12. Is 12 equal to 12? Yes, so that answer gets to stay. Now let's check negative 9. So if we were going to type that into our calculator, so this one, x is equal to 7 gets to stay. So then if we check our other answer, negative 9, we'll do the same thing. So 3, and then times negative 9 plus 1 raised to the 2/3 power, it better equal 12. So you'll type that into your calculator. Now I showed you, and I'm telling you, number that one works as well. So we get to keep both answers. And x is equal to -9. We get to keep both answers on this one. I promise there'll be ones with extraneous solutions. Questions on that? Okay. Do you want me to do number 7, or do you feel like you're ready to go? Do number 7. Okay. One more, and then I'll let you work. So we have 3 times x minus 2 raised to the 3/4 power is equal to 24. So the first thing we've got to do is isolate the radical. So I'm going to divide both sides by 3. So that leaves me with x minus 2 raised to the 3/4 power is equal to 24 divided by 3 is 8. So those divided out. So then now we've isolated our radical. So we've got to get rid of the radical. And since it's written as a rational exponent, we'll raise both sides to the reciprocal of that. So the reciprocal would be 4/3. Raise both sides to 4/3. So then over here on the left, our roots cancel out. And we're left with x minus 2. So we have x minus 2 is equal to 8 to the 4/3. Now I got to decide, do I have an even root? No, it's an odd root. So the answer is what the answer is. So you'll type in +8 raised to the 4/3 power. 16. So we get is equal to 16. We don't put plus and minus. This was not an even root. And then we'll solve for x piece by piece. So I'll add 2 to both sides of the equation. So we get x is equal to 18. Now let's see if we can keep it. If not, we won't circle it. We'll check it by plugging it back in. So we'll be doing in our calculator 3 times 18 minus 2 raised to the 3/4 power, putting it in parentheses, is equal to 24. It better be equal to 24 when you type this part into your calculator. If you do, number 7, it works, right? Okay, so we get 24 is equal to 24. So we get to keep that solution. All right, I'm going to let you guys practice. So now you're going to do problems 5 through 8. We just did 2 of them together. 5 through 8, we just did 2 of them together. So really that's just 2 problems. Okay. All right. So we're going to do number 9 together. Okay, this one's a little bit trickier. So we're going to do number 9. But really, it's not too bad. It's really not. Because we'll use our calculator for the hard part. And I did make my class last year do it by hand. I'm not going to make you guys do it by hand. All right, so looking at this one, we know that we have to, when solving radical equations, we have to isolate the radical, right? We've got to get the radical all by itself. So what should I do? Add 5 to both sides of the equation. Very good. So we're going to add 5. So then over here on the left, I have the square root of x plus 7 is equal to, can you add x plus 5? Can you add those two things? No, so we'll just write it x plus 5. Questions on that? That is what we have, right? All right, so then from there, once we've isolated the radical, the next step is to get rid of the radical applying the inverse. What's the inverse of square root? Square. So we're going to square both sides of the equation. Now notice how I put x plus 5 in parentheses. You have to do that. It's x plus 5, that whole side raised to the whatever power. So then from there, on the left, our root cancels out with our power, leaving us with x plus 7. That's equal to x plus 5 raised to the second power. Now this is how you would do it by hand, okay? You would multiply that out by rewriting it as x plus 5 times x plus 5. Double distribute, combine like terms, right? Everybody? Then we would make sure our equation is set equal to 0. So we would bring this x over and this 7 over, right? And then from there, it would be quadratic, and we would solve using the quadratic formula. Does everybody understand how you would do it by hand? Okay, now we could just use our calculator, because what we really have is 2 different functions. We have this x plus 7, that's a linear function, right? Everybody? And we have this, when is that equal to, when is that linear function equal to this quadratic? So we're going to say, well, if where they're equals, where they intersect, right? Where they're equals, where they intersect. So now this is where I'm going to just use my calculator. So I'm going to use my calculator. I'm going to graph this line, I'm going to graph this quadratic, and I'm going to see where they intersect. That's the x values. So the x values where they intersect. So, all right, let's pull up our calculator. So you go to y equals, in y1, I'm going to type in x plus 9. So x plus 9. That is our line. X plus 7. And then in y2, it's parentheses x plus 5 raised to the second power. So caret 2. Is everybody good? Now I hit graph. And my window's not very good. I'm going to make it a little bit smaller. You might have to make it bigger or smaller. If you have a quadratic, how many solutions will you have? 2. So if on your graph you don't get 2, it's because your window's not big enough. All right, so I'm going to change this to be, I don't know. I'm just going to make it a little bit smaller. Okay. Let's see. All right, so that's my graph. Does everybody see? There's my line. There's my quadratic. They intersect at that x value and that x value. Does everybody see it? Now we're going to use our calculator to see where they intersect. So I do second trace, and I go down to intersect. So it says first curve. Now notice I'm clear up here. So everybody pay close attention, because half of you don't pay attention to the calculator part, and then you can't do it on your own. And it kind of makes me mad, because I'm like, you should have been paying attention and trying it yourself. So here we go. It says first curve. We're on the line. Now notice we're over here on the line. We're close to that point, right? Okay, so I hit enter. Now it says second curve. It automatically, it's still on the line. Why is it on the line still? I think it is. No, it's not. So now it's on the quadratic. Does everybody see how up here it tells you it's on the quadratic? Does everybody see that? Okay, so I hit enter again. Now it says guess. You hit enter, and it's going to go. Now look, it's that intersection point. Does everybody see how it's sitting on that intersection point? So x is equal to -3. So that's one of our answers. So x is equal to -3 is one of our answers. And then we've got to find the other intersection point. So you'll have to do second trace again. So second trace and then intersect. Now this time, if you do that exact same thing, it's just going to do that same point. So we've got to scroll. So notice we're on the line x plus 7. I'm going to scroll and be on the other side, but I'm still on the line. Do you see how now I'm closer to that point? So I hit enter. Now it says second curve. Do you see how I'm pretty close to that line? I'm on the quadratic. I hit enter again. Now it says, do you want me to guess? Hit enter again. It's intersecting at, I check and make sure it's landing on this one. It's intersecting at -6. So x is equal to -6. How many of you prefer that method over doing the, if we would have done the quadratic formula, guys, or solved by factoring, we would have got the same answer. How many prefer that method? We got it the same way, so I don't care how you get your answers, as long as you get them right. So go ahead and do that method. All right, now you have to check your answers. I'm not going to do that. Actually, I am, because this one has an extraneous solution. So everybody look with me. If I plug in -3 right in for x, we'll have, let's just do it thinking about it. We have -3 plus 7, which is 4, right? So the square root of 4 is 2. 2 minus 5 is 2 minus 5 is -3. Is -3 equal to -3? Yes. Okay, so then you check -6. Now I'm going to actually do that one. So we're plugging in -6. What's -6 plus 7? Square root of 1. So we have the square root of 1, which is, so we have 1 minus 5, and that better be equal to -6. What's 1 minus 5? Nope, 1 minus 5. -4. -4 is equal to -6. True statement? Yeah. No, -4 is not equal to -6. So guys, we throw that solution out. It's an extraneous solution. Yes. No, but you would have, right? Because you would have done both. Because we did it correctly. It was you have to check them both. So then you throw that answer out. So x is equal to -3. Does that make sense, everybody? Okay. All right. So number 12. Really quick. Let's go through number 12. So we have the square root of x minus 1 minus the square root of x plus 5 is equal to 0. Our first step is to isolate the radical. So there's two radicals. So we have to get one radical on one side of the equation and the other radical on the other side. So to get this radical over, I'm going to add it to both sides. Add the square root of 5x plus 5 to both sides. Does everybody see what I just did? That adds up to be 0, leaving us with the square root of x minus 1 is equal to the square root of 5x plus 5. Is everybody okay with that? We've isolated the radical. Now you'll undo the radical using the correct inverse. This is the square root. What undoes square roots? Squares. So we have to do it to both sides of the equation. Well, luckily in this one, what happens? Our root cancels out with our power, leaving us with 7x minus 1. Over here, on the right, our root cancels out with our power and happens to give us 5x plus 5. Then from there, to solve for x, wouldn't we just algebraically get x alone? So I'm going to subtract 5x from both sides. 7x minus 5x. 2x. So we have 2x minus 1 is equal to 5. Add 1. So we have 2x is equal to 6. Divide both sides by 2. So we get x is equal to 3. Then we would check our answer by plugging it back in. And yes, on this one, I'm not going to take the time to check it. It is good. Does that make sense? Okay. So finish the worksheet. You should be able to finish now. Do the rest of the time.